Hi, I am Abhijit Awasthi. This talk summarizes a subset selection approach of error-driven data collection for personalizing speech recognition models to accented speech. This is joint work with Aman Kansal, Sunita Saravgi, and Preeti Jyoti at IIT Bombay. English ASR models often struggle with accented speech. On a dataset containing speech from native speakers of a wide variety of Indian languages, we found that ASR models perform rather poorly in comparison to native English speech, where the word error rates were around just 5%. Fine-tuning the ASR model on a limited amount of accented speech is a common way of personalizing ASR models for accented speakers. Speech is often collected by asking the speaker to read some sentences selected from a text corpus. In practice, this kind of data collection is often constrained by a limited budget for recording users' speech. Thus, we wish to identify a subset of sentences from a large corpus whose utterances provide better adaptation of the ASR model after fine-tuning in comparison to a random subset of sentences. We propose that the chosen subset of sentences should be phonetically diverse, and the sentence utterances should be hard for the ASR to recognize. Identifying sentences that are hard for the ASR is a non-trivial problem since we do not have speech recordings beforehand. To find such hard sentences, we learn error models that help us identify the phonemes in a given sentence that an ASR may misrecognize. We assign higher scores to the sentences that, as per the error model, contain a higher number of misrecognized phonemes. As a simple example, consider a two-word sentence with bank. An error model takes as input the given sentence and converts it into a phoneme sequence using a grapheme to phoneme converter. Each phoneme is then assigned a probability of being misrecognized in the ASR transcript. The error model is composed of a simple bi-LSTM network trained for the task of labeling each phoneme as being misrecognized or not. To train the error model, we first record speaker utterances for a small seed set of randomly chosen sentences. We then invoke the ASR to generate the transcripts for these seed utterances. Now, using the edit distance or Levenstein's algorithm, we align the ASR-generated transcripts with the goal transcripts in the phoneme space. The alignments are then utilized to obtain the target labels for training the error model. We can now utilize a trained error model to score sentences by simply summing up the probability of each phoneme being misrecognized and normalizing by the length of phoneme sequence to avoid bias towards longer sentences. By selecting the top case scoring sentences in our subset, we try to maximize the sentences whose utterances are more likely to be misrecognized by the ASR. However, we observed that this method reduces the phonetic diversity of the selected subset by selecting repetitive patterns. To overcome this problem, we now select the sentences iteratively such that score of a candidate sentence now depends upon the phonetic content of the already selected set. To maintain phonetic diversity, we associate diminishing returns with the selection of a phoneme that already has a good count in the so far selected set of sentences. Diminishing returns are realized with help of a submodular function. Please check out our paper for more details about this method. In our experiments, we include speakers from 8 different native languages. We find that error models help us discover subsets of sentences whose utterances are significantly difficult for the ASR to recognize in comparison to randomly selected sentences. For each speaker, we plot the minutes of recorded speech along the x-axis and reductions in word error rate after fine-tuning the ASR along the y-axis. We observe that fine-tuning on the sentences selected by the error model consistently provides higher word error rate reductions in comparison to random selection baseline across all the speakers. To know more about our work, please read our paper on arXiv or contact us at the following emails. Thank you.